Welcome to AWS reInvent 2020. In this session for Zero Code Data Preparation with AWS Glue DataBrew. My name is Surbi Dangi, and I'm a Senior Product Manager for DataBrew. Today, our customers are using data at an unprecedented pace for analytics and machine learning. With the explosion in the amount of data, sources, and the type of data flowing in, data preparation can cost businesses valuable time and resources if not done efficiently. With this, in today's session, we have an exciting agenda to talk about. We're going to be covering the challenges that customers face with data preparation, how customers can take advantage of self-service data preparation with DataBrew in an organization. We'll also discuss key features of the tool, take DataBrew out for a spin with an interactive demo, and then wrap up with some very common use cases that our customers are using DataBrew for. To take a step back, with the constant influx of information, customers are scrambling to capture all the right data points, organize and process the data, and convert it into actionable insights. Yet in the hustle to transform raw data into usable information, we tend to forget how sophisticated and challenging the data preparation process is, and how many individuals in an organization it encompasses. The way that this came about is that a lot of customers tell us that they love the scalability and the flexibility of code-based data preparation in services like AWS Glue today, but they would also benefit from allowing business users, data analysts, data scientists to visually explore and experiment with data independently without writing any code. So let's take a look at what data preparation looks like today. Preparing data for analytics and machine learning involves several necessary and time-consuming tasks. These include things like extracting data, cleaning data, normalizing it to specific forms, loading them into databases, data warehouses, and the data lake, and finally orchestrating scalable ETL workflows at scale. For extracting, orchestrating, and loading data at scale, data engineers and ETL developers typically are skilled in SQL or programming languages like Python and Scala, and they go and sort of prepare their data in code-based environments. We've seen sort of ETL developers love the new, more visual interfaces of modern ETL tools, and so AWS recently introduced AWS Glue Studio, which is a new visual interface to help ETL developers author, run, and monitor ETL jobs without having to write code. Once this data has been reliably moved, the underlying data still needs to be prepared. It still needs to be cleaned and normalized. And data scientists and data analysts that operate in lines of business understand this data best and sort of want to get their hands on that data. In eventuality, code-based heavy lifting is required today to prepare data at scale. In an effort to spot anomalies in the data, we have highly skilled sort of data engineers and ETL developers writing custom workflows and custom code to pull data from different sources, then pivot, transform, slice and dice this data multiple times before they can iterate with data analysts and data scientists to identify what needs to be fixed in the data. So you'll find data engineers, ETL developers, and then of course the data analysts and data scientists who are very familiar with this data often work together to sort of determine the kind of transformations more upstream in the data preparation process. After they've developed these transforms, data engineers and data in ETL developers still need to sort of schedule custom workflows on an ongoing basis so new incoming data can automatically be transformed. This is a pretty elaborate process where each time a data analyst, let's say, finds a mistake in a specific cell in the data or finds an anomaly or a pattern mismatch, they go back to sort of data engineering, they go back to the ETL developers, and each time a transformation needs to be changed or added, everyone sort of needs to get involved again, and all of these data preparation tasks need to be orchestrated again. This iterative process, as you can imagine, can take several weeks or even sometimes months to complete. And as a result, customers end up spending up to 80% of their time cleaning and normalizing data instead of analyzing the data and extracting value from it. With this, to summarize, there are several challenges with traditional data preparation today. First, of course, is traditional data preparation at scale is still largely manual. It's done by cherry picking small samples of the data in Excel sheets or in Jupyter Notebook environments. It needs a lot of code-based heavy lifting for it to really work at scale. And with more and more data lake, with more and more data that's sitting in your data lake or in your data warehouses, different kinds of data, structured, unstructured, data from logs, data from third-party applications, it's becoming more and more important to have ad hoc cleaning as part of the data preparation process. Second, we notice that data arrives sort of in so many different formats. It's compressed, partitioned, periodic, transactional, and oftentimes to enable business users, large amounts of that data still needs to be moved into silos or even outside the company's virtual private network or VPC to be able to be prepped or really explored even for analyses. These cause security concerns at times for customers. And finally, as you go more and more upstream in the data consumer chain, the transformations are very specific to the context of the meaning of the data. So a specific cell might be out of place, or just a specific format of the data might be out of place. And so these spot fixes need to be made. In the case of this sort of dependent process, there's a low factor of reuse of work where when a data analyst spots an anomaly, can they, number one, be empowered to go ahead and fix that anomaly? And then number two, can the data engineering team or can the data source actually take in that anomaly and have a fix for it that's already been done by the data analyst? So tooling is very specific to point use cases today and does not look at data preparation as a whole and how an organization can be empowered by it with some reusability factor. In the spirit of being customer obsessed, we listened to our customer, we listened to their pain points, and understood their challenges in data preparation, and launched AWS Glue DataBrew just a few weeks ago. For those of you who are not very familiar with AWS Glue, it is our serverless data integration service that makes it easy to discover, prepare, combine data for analytics, machine learning, and application development. AWS Glue provides both visual and code-based interfaces to make overall data integration easier. Specifically, today I'm going to share more about AWS Glue DataBrew. DataBrew is a new visual data preparation tool that enables data analysts and data scientists to clean and normalize data without writing any code. It provides these users with powerful capabilities to explore, manipulate, and merge new data sources, all without the assistance of code, and helps them self-service data preparation tasks that they come across in their work. When we talk about data analysts and data scientists, it's really important to understand that these are many different. They come in many teams. They come in many roles and job functions. Analysts such as legal analysts, marketing analysts, financial analysts, environmental analysts, as well as data scientists such as researchers that are researching on vaccine development, for example, where their core job function is not to learn Python, but really to work with data to understand the patterns and really analyze the data. For all of these personas and users, DataBrew provides an easy-to-use platform for them to prepare their data directly from data lakes. With Glue DataBrew, end users can easily sort of access and visually explore data across their data stores. So that includes your Amazon S3 data lake, the Amazon Redshift data warehouse, and the Amazon RDS databases. You can also upload a file from your local disk, which we've seen is a very common use case amongst the analyst persona, or even connect to data sources that are coming from third-party systems like Salesforce, Marketo, etc. Customers can also choose from over 250 built-in transformations. These transformations really help you combine, pivot, and transpose data without writing any code. It recommends cleaning and normalization steps, things like filtering anomalies in your data, really recognizing and dealing with invalid or misclassified values. You can also look at duplicate data, as well as any data that you need to standardize. So things like datetime formats, or even just uppercase to lowercase characters. DataBrew also comes with a set of transformations for data science, and these are really helpful where we use sort of advanced machine learning techniques like natural language processing directly within our transformation. So you can actually convert yearly, for example, the word yearly to year long, or year long to year. So it really sort of helps you convert common words to their base or root form. And this is just one example of the data science transformations that we provide. You can sort of save these cleaning and normalization steps into a workflow, which is typically called a recipe. And this recipe can then automatically be run on future incoming data. As you can see, there's a lot of operation on the data, and a lot of transformations that you can do on the data using DataBrew. And with that, another important aspect of this is being able to understand what changed at what point in time, by who, which transformations were applied on which data sets, and how did the data change and evolve with the usage of DataBrew. And so we provide a very visual lineage view for all operations that happen on the data. And lastly, being on the data lake, scale is important, and being able to operate at scale and being able to schedule these transformations to run repeatedly on new incoming data is part of DataBrew. And all of DataBrew's actions are serverless. So DataBrew is serverless, fully managed. You don't have to provision, you don't have to configure, provision, or manage any resources to operate DataBrew. With this, we're going to switch over to a quick demo of the product and then cover some popular use cases. So DataBrew can be accessed through the analytics category on the AWS Management Console. And when you land on the console, you can see the way to sort of create a project. There are some key entities in DataBrew, such as data sets, projects, recipes, and jobs. And in these, you'll notice you can go ahead and sort of create a data set when you land on the DataBrew console. You can browse your S3 buckets or connect through the Glue data catalog, your Redshift tables, RDS tables, or even upload a file from your local disk. So in this case, I'm going to take a New York City bike data set and just look at sort of what this data set contains, what columns exist in these. Once I've created a data set, I can go ahead and sort of not only take a look at the sample, but understand over 40 to 50 statistics on how this data is laid out. So things like duplicate values, missing values, as well as correlations for all numerical values in this data set. I'm starting to sort of get a picture of this data set, but this data set, for example, has a bike ID column. And so there I'm interested in the cardinality to make sure the rows are unique. I'm also interested in making sure that there's no anomaly in the bike ID. So I'm going to take a quick glance. Then I also look at the user type to understand how many user types even exist in this data set. Once I'm done, then I can switch over to the lineage view and just understand how many projects are connected to this, what are the jobs that are running. And so in this case, I'm going to go ahead and actually open this data set up to do some data preparation. So when I click on the project, I land into a visual working window where we're working with a first n sample of this data set. As you can see, when I click on column headers, you can really sort of understand statistics, detailed statistics about each individual column. And I notice we have lat-long columns, and maybe for my analysis, I want to actually combine these two columns. So I would just go ahead and initiate a transformation to merge these with a separator, rename the column, and then what this does is gives me a real-time preview of what my column is going to look like when I apply this transformation. So this is a really easy way to sort of visually understand the impact of your transformation and what that's doing to your data. Next, I'm going to go ahead and look at just sort of look at some aggregates for this data just to understand it. So I'm interested in understanding, based on my user type, how many bike hours, or what is the time duration, the trip duration for each of the bike types. I can also look at other analyses that I can add on to this data set. Once I select sort of my attributes, I can see an immediate preview of this analysis, and this is really helpful, especially when you're preparing data for machine learning and when you're really trying to understand or engineer your features for your machine learning models. So in this case, it looks good, my customer subscriber values, and so I'm going to pull those columns back into my visual working window. Once I've done that, as you can see on the right-hand side, every time I've applied a transformation, it's added it to what we call a recipe. One more transformation that I'm going to do is for my machine learning models, they don't take. I would give them numerical values, and so I quickly went ahead and looked at just two values in my sample. Also went and looked at the fact that there are two values that exist in my population, and then mapped all two values. Let's say there was actually a lifetime value that didn't show up in my sample but existed in my population. I can quickly sort of check between the profile view and the grid view and make sure it's all solid. One of the last things, my analysis is incomplete without looking at maintenance data. So what I'm doing is bringing in bike maintenance data via join, specifying my join keys and looking at a preview. What this helps me do is really bring in data sets from disparate sources. I joined a CSV with an Excel file here just to understand how does maintenance, like a recent maintenance, impact my trip duration for the bike. And so this is a really great way, to experiment with all kinds of joins. You can look at an inner, outer, etc. This looks quite good, but clearly I've kind of messed up my schema a little bit. So I can go ahead into the schema view, just double click on columns, rename them, change, hide them, delete them as required. And once I'm ready, I can go ahead and sort of rename this column. This will get added as a recipe step once again. When I'm ready with my recipe, I can go ahead and sort of review the changes I've made. I can even switch around samples and then really sort of understand that this recipe that I've created actually applies to my data set and works well. Once I'm done, remember we've been working on just a first and 500 row sample. I can go ahead and now apply this recipe to the population data. So now I'm running it on the actual data set. And what I did was just specified an S3 location of where to store my output. So in a nutshell, with all of that exploration, I basically took a data set from S3, joined it with another data set, created some transformations, ran a profile, and ran an output. And so this visual sort of explorer really helps you understand and keep track of all the changes that are happening in your data set. So in a nutshell, this is sort of one of the most common workflows in DataBrew, and you can go ahead and experiment with data. You can also go ahead and sort of develop interesting use cases with this foundation. So next, we're going to go through sort of what we really looked at. We're going to go and do a quick recap of what you looked at in the demo. So in this demo, you saw how we could profile a large data set, use those statistics to inform transformations on your sample that you're visually exploring, and then apply these transformations back to the large data set. In addition, you can also operationalize these at scale. So recipes are reusable. You can publish them. So 2 data analysts that are collaborating can each publish recipes in the account. And you can import them back into the project for reuse. You can also use APIs to perform all the actions that you saw on the UI, and really schedule jobs. So every time you have a new data set that lands in an S3 bucket, you can parameterize the input file name to pick up that latest data set, and then just schedule a job to do some lightweight to sort of perform these transformations pretty easily and orchestrate them at scale. So we're going to talk through, now that you have a glimpse of what DataBrew looks like, we're going to talk through some common sort of use cases that we've seen customers use DataBrew with. One of the most popular ones are ad hoc experimentation and data exploration for business reporting. And data analysts commonly sort of bring data either from a local file on their, like an Excel spreadsheet on their computer. You'd be surprised how many spreadsheets still get passed around in organizations, or they bring data that's been made available from the catalog to them, the data catalog from Glue. Once they do that, they connect to this data, they perform the analysis in DataBrew, and then put the files back into S3. From S3, you can connect to, you can create a Spice dataset in Amazon QuickSight, which then automatically pulls in new data as it lands and refreshes your business report. So this is a really great use case for your common monthly, weekly, or daily reports, as well as ad hoc analyses that you need to do when you first get a hold of the data set and need to get familiar with it. So things like enriching data with joins, unions is common. Let's say you have monthly data that comes in and you want to put in a yearly report. Just specify a folder in DataBrew. Let's say you want to update the schema in bulk. Again, create a recipe and then use a recipe on different data sets to just harmonize all of the schema. Another popular use case that we've seen is data quality, and we see this very commonly with customers that get a lot of data feeds from different providers, and they're really looking to sort of set up business rules. So what they do is every time a data set comes in, they first profile it with DataBrew, and then using EventBridge and Lambda functions, you can code up specific business rules that apply to the data. certain things, certain interesting sort of use cases here. You want to compare profiles of two data sets really to understand the difference if something is wrong. You also want to understand if a specific data set needs to be marked for manual review. And so these are very interesting use cases where with a variety of data sets now in the system, different kinds, different shapes, sizes, formats, data quality and its practice in the organization becomes increasingly important. So data profiles as well as all the statistics around it become critical. Pre-processing data for machine learning has been sort of very critical in even training machine learning models. And so customers typically bring data from S3, go ahead and look at that data in DataBrew, really easily feature engineer it. So with DataBrew, you can categorically map data, you can tokenize text columns, normalize them, really just do data sanity before it goes into a machine learning model. And so a lot of folks use DataBrew as a plugin to their Jupyter notebooks. And directly within the notebook environment, they data prep on one tab with DataBrew and then continue coding in their notebook environment on another tab in a Jupyter notebook. So take a look at the DataBrew Jupyter Lab plugin for accelerating some of the machine learning pre-processing that happens with data today. And one of the final sort of use cases I want to talk about is orchestrating data preparation workflows. Now, there's a lot of ad hoc, one-off data preparation, but truly sort of the efficiencies are driven when you can really reuse a lot of the data preparation that individuals are doing in different teams. And so what you can do is take, let's say, data that's sitting in Redshift and really bring it into DataBrew, and then once data is prepared in DataBrew, when you run the recipe, you can then trigger, let's say, a glue crawler to put that data back into Redshift in your data catalog. And of course, this is just one such example of orchestrating data preparation, but you can see similar sort of use cases where you can orchestrate these things via step functions or even Lambda functions. With this, I want to leave you with the availability and how to use DataBrew. DataBrew is generally available. It's accessible via the AWS Management Console APIs, as well as a plugin for Jupyter Notebooks. And you can, as you can see, getting started with DataBrew is very easy. You can try one of our sample data sets or even bring your data sets and start brewing. Feel free to reach out to us at databrewfeedback@amazon.com. And thank you so much for taking the time to attend this session. I hope you enjoyed it and learned something today.